Hi, Timothy Unkert here. Welcome to my late 2022 Python tutorial. This is part 6, and we're going to cover sets in this part of the tutorial. If you want to watch parts 1 through 5, I'll leave links to those in the descriptions below. And I'm going to start with my file naming convention. So we're going to start with 33A sets. So let's create a new file here. Python file, we're going to call it 033a underscore sets, and we'll get started with that. And go here, open that up. Okay, so a set, let's make a comment here. A set is unordered, unchangeable, but you can add and remove, and it is not indexed. Okay, so there isn't an order to it. We'll make a note that you can, even though you can't change, say, a particular item, you can add and remove items. Okay, so let's start. We'll have my names set, and to create a set, we're going to use open and closing curly braces. So similar to a dictionary, except we don't have a key value pair, we just have our elements. So I'm going to have a name Tim, a name Sarah, a name Joe, a name John, and a name Amy. Okay, and we'll just print out my name set. So we'll start by just printing out the set here, and I'm going to run this, and we see we get our set. Now, the first time when we run this, we get Amy first, then Joe, Sarah, John, Tim. So it's not alphabetical order. If we run it again, this time we got Joe, Sarah, Tim, Amy, John. If we run it again, we got Amy at front, but John, then Tim. Run it again. We got Sarah now. So there is no particular order. So I'm just demonstrating each time I run this, it's printing out the set in a different order. Okay. Another thing about sets is sets cannot contain duplicates. Okay, so we could say something like my other set, and I'm going to add a duplicate here. So I'm going to add two Tims. So let's do Tim and Tim. Casing is important, of course. And then let's do Sarah, Joe, Matt, and we'll do Amy. Okay, and now I'm going to print my other set, and we'll run that. And if we run this, we see that my other set is the second set that's printed. We only have one Tim. So even though I tried to put a duplicate in, it's saying, no, this is a set. We can't do that. You can't have duplicates. Okay. Another thing to note is, or you may wonder, why are sets important? Well, sets are important. It's an important data structure. And other data structures and algorithms, courses you might hear about hash maps or hash tables. There are certain instances, I won't cover it in this tutorial, but there are certain instances where using a set may be more advantageous than, say, using a list. Okay, so it's an important data set to know about. All right, and I think that's all I wanted to cover for that file. So let's go and create another file here. We're going to call this, let's create a new file. We'll call it 033b. So new Python file here, 033b underscore sets, .py. If you're not using an IDE, you want to have that .py extension. Mine just adds it for me when I say Python file. Okay, so I'm going to create a my underscore name set, and we'll start. We'll have some of the same names. So Tim, Sarah. We'll try and do a duplicate with Sarah, Joe, and we'll try and do a duplicate with Tim. Okay, so we're attempting to put two duplicates in there, and we can figure out the length of the set with the len function, which we can use with a lot of other data types as well. So we can print the length of my name set. Now, if we run this, we'll see we get 3, all right, because we really only have Tim, Sarah, and Joe. So it does not count the duplicates, right, because sets cannot have duplicates. So we get 3 in this particular instance. I'm going to create another set called my underscore rando set, and we're going to have some different data types. So we're going to do true, false, none, a string Tim, an integer, and then a tuple 1, 2, 3. Okay. If we now run this program, we see we get exit code 0, so we finished with no errors, right? But let's say, let me copy this, then comment it out, put this here, and let's try and change this now to a list. Okay, now let's run it, see what happens. And we get a type error. It says unhashable type list. So we can't pass a list into a set. Okay, not allowed to do that. Let's also create a dictionary. Let's have name, Timothy, just a very short dictionary, age, 46. So 2 items in the dictionary. Let's try and run that. And again, we're getting exit code 1, and we're getting this type error, unhashable type dict for dictionary. So we can't put that in, but we can put in our tuple, right? So we can go back here, and we could even have some kind of names tuple like Tim, Sarah, Joe. And if we run this, we get exit code 0. So it's fine with the tuple. It's not fine with passing in a list or a dictionary. Okay, that's what I wanted to point out in that video. And we're going to keep going with sets. I have about 14 files covering sets in this tutorial today. So there's a lot to cover. So we're going to do 033c underscore sets. Okay, and we'll go about ways of creating a set. So we'll create a set. I'm going to make that comment here. And let's try this way. So we say my underscore set equals, we use the set keyword, and we'll pass in just 1, 2, 3, 4, 5. Okay. Now, if we run this, we're getting exit code 1. There's the type error. Set expected at most 1 argument got 5. Okay. So we have to do something different. This will cause an error. So this will throw an error. Okay. And let's just comment that out. Let's do my underscore set, and let's do 1 argument. So within the parentheses, we'll pass in a tuple 1, 2, 3, 4, 5. Okay. And then we'll print my set here, and we'll run it. And we get the set 1, 2, 3, 4, 5. So that does work. Now you notice here that my IDE is giving me a warning. And what I can do is click on that. And it says function call can be replaced with set literal. So now if I click on this and do show quick fixes, we can replace the function call with the set literal. So let's do that. And if we do that, it just writes the set the other way we were declaring the set in the previous video. So that's what they mean by a set literal. Sorry. And I think that's all I really want to cover with that. The GitHub repo has a couple other. Oh, actually, no. Sorry. Let me cover a few other things. So I can also do my other set, and let's do the keyword set, and we'll pass in a list here. So 1, 2, 3, 4, 5, and we'll print my other set here. So if we run this, we get the same thing, 1, 2, 3, 4, 5 as a set. Again, we're getting that warning here. Function call can be replaced with set literal. So I could just write this with just the curly braces, 1, 2, 3, 4, 5 inside of that. And that would be a set literal. So if you see that warning, that's what that means. I just wanted to point that out. Okay, so now we're going to create another file. And I'm keeping these files short, so just one little bite-sized chunk at a time. That's the way I'm going to do it. So hopefully that works for you. So we have 033D set union here. Okay, so we're going to create 2 sets. Set 1, and my naming isn't great for the sets, but it is what it is. So we have 1, 2, 3, 4, 5, and then set 2 is we're going to have 4, 5, 6, 7, 8. And what we're going to do is a union, which is kind of like what you had in math, where you have, like, let's just make a comment here. So set 1, union, set 2. So it's going to combine the elements to create a new set. If we say something like set 3 equals set 1 dot, and we've got a bunch of methods. One of them is union, and then we can pass in the other set. So set 3 is going to be a set of distinct items containing all the elements in set 1 and set 2. And if we print set 3, well, let's see what we get. So we get 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we don't get duplicates because we're dealing with sets, but we do get every element that is in both sets. Okay, so that's union. All right, let's make another file. This is going to be 033E, and we're going to call this set intersection. Okay. All right, so we're going to create, again, two sets. So set 1, we'll have it be 1, 2, 3, 4, 5. Set 2 is going to be 4, 5, 6, 7, 8. Okay, and then we'll say set 3 equals set 1 dot. This time we'll do intersection, okay, of set 2. All right, so we're going to now get the elements that they share in common. So we should have set 3 should be a set of 4 and 5, just like so. So let's print out set 3. That's set 43, print out set 3. And we'll run it, and we get 4 and 5. And we're good to go with that one, okay? Next file I want to create, we're going to talk about adding to a set. So we're going to do a new Python file called 033f set add. Okay, and we'll have a names underscore set, and we'll have 3 names. Let's do Timothy, Aaron, and Joe. And then we'll do name set. We'll do dot. It's a method. Dot add, and we'll add Sarah. Okay. Now, when we print the names set, we're going to get 4 items. So we're going to get Timothy, Aaron, Sarah, and Joe. And the order will change, again, running sets. Run it again. We get Timothy, Aaron, Sarah, Joe. So it keeps doing that, but it should switch about because, again, the set doesn't have a particular order. Okay, so that was that file. That's adding. Let's make a new Python file. Let's call this 033 g underscore set underscore remove. And now we'll create a name set. We'll put a few more names in there. So we'll have Timothy, Tim, Sarah, Joe, and Joseph. And we'll note that Timothy and Joseph are just more formal names of Tim and Joe. So we want to remove those. So we're going to say name set dot method. You do a dot and then the method name. So we're going to remove the method or the element Timothy, and then we'll do name set dot remove Joseph. Okay, and now we'll print the names set here. And if we print it, we see we've got Joe, Sarah, and Tim. We've removed Timothy and Joseph. Okay, now it should be important to note that if I take my name set here and I try and remove something that's not in there, let's try and remove John. Okay, we'll see what happens here. We're going to get exit code 1, we get a key error since John is not in the set. Trying to remove something that's not in the set will cause an error. There's another way to do that. I'll talk about that in a couple of files. Okay. All right. Next, we want to talk about update with set. So we're going to create a new Python file, 033h underscore set underscore update. And we'll create a names set, and that'll be Tim, Joe, Aaron. And we'll do some other names. And we'll do Matt and Mark. And we'll do some more names. And we'll do Sarah and Amy. And we're going to take these names set, and we're going to do .update. And we can pass in as many arguments as we want here. So we're going to pass in other names, more names, and I'm also going to pass in a list. We do want to pass in some iterables here. So 1, 2, 3, and then let's print my name set here. So if we print this, we get 1, 2, 3, Tim, Joe, Mark, Aaron, Matt, Amy, Sarah. Okay, so that's update. It's a little bit different. Let's talk about next about difference. So I'm going to create another file. Let's see, 033i, and this is going to be set difference. Okay, so we'll create a names one, and we'll call that Tim, or we'll give that items Tim, Timothy, Barb, and Sarah. And then we'll do names 2, which will be Tim, Sarah, and Joe. Okay. And now what we're going to do is print the difference between names 1 and names 2. So names 1 minus names 2. And we'll run this. If we run this, we get the difference, which is Timothy and Barb. So this is printing elements unique to set 1. So it prints elements unique to set 1. Okay. Now, if I want to do elements unique to set 2, I can print names 2 minus names 1. And if I run this now, I get Joe. So Joe is unique to set 2. So this prints elements unique to set 2. Okay. All right. So that's the difference. Let's talk about discard. Okay. So new Python file here. And we're going to call this 033j set discard. Okay. And let's create a set of names. So we're just going to say Timothy, Joe, Aaron, and Sarah. And what I'm going to do here is I'm going to do names.discard, and I'm going to pass in Joseph, which isn't in the set. Okay, and we're going to see what happens. All right. So we see we have exit code 0. Even though it wasn't in the set, there are no errors thrown. So, remove, when we use that, if we used remove, we'd get an error. So if I said names.remove, and let's do Tim, because he's not in the list, or in the set rather, and we get a key error. Okay, so we can't do remove. So we'll say this will not throw an error. This will throw an error. Okay, so that's the difference between the two. All right, and then next file, let's talk about set with in and not. Okay, so we're going to do new Python file. We'll do 033k underscore set underscore in underscore not .py. Okay, so we'll do names 1, and we'll have Timothy, Tim, Sarah, and Barb. And then names 2 will be Timothy, Sarah, and Barb. Okay, and I'm going to create a variable. We'll call it unique to set 1 equals names 1 minus names 2. And then unique, let's call this unique to set 2 equals names 2 minus names 1. Okay, and I'll say something like if Tim, so we're checking it if it's in. So should it be in just set 1? Well, yes. Okay, so it should be. So if I say if Tim in unique to set 1, I'm going to print double quotes here. I'll do escape character around Tim so I can get some quotes in there. So I say Tim is only in set 1. Oh, we need, what do we do here? Okay, so I say Tim is only in set 1. So let's now run it. And we get Tim is only in set 1. Okay. We can also use not. So we could say if Tim not in unique to set 2, we'll say we'll print out and we'll do Tim is not unique to set 2 or names 2. So this should work too because names 2 does not have Tim, right? It has Timothy, which is different. All right, so if we run this, we get Tim is not unique to set 2. So that's how we can use not in. Okay. All right, another file. New Python file 033 k underscore set symmetric difference. Okay, and okay, so we'll create 2 sets. So names 1 is going to be Tim, Timothy, Sarah, and Aaron. Names 2 is going to be Timothy, Sarah, Joe, and Matt. And we'll create a variable called sim underscore diff equals names 1 dot, and we can use a method called symmetric difference names 2. Okay, and we'll print the symmetric difference here. Okay, so if we run this, we get Tim, Aaron, Joe, and Matt. Okay, so Tim, Aaron, Joe, and Matt. So what we're printing is what is not the intersection of these 2 sets. So let's put that as a comment. So we are printing what is not in the intersection of these 2 sets. Okay, that's symmetric difference. And there's other methods as well. I'll let you play around with those. Next one, for sets, we have let's create a new Python file. Let's do 033L underscore set underscore is subset. We're talking about is superset as well. I'm going to create names 1 as a set, and we're going to have Tim, Sarah, Joe, and then names 2 is going to be Tim, Timothy, Sarah, Joe, and Joseph. Okay. And what we can do is check if one set is a subset of another. So we could print, and we could do names one dot is subset of names two. Now this is going to give me a Boolean value, so it's going to either print true or false. In this particular case, it is a subset of names two, so it's going to print true. So let's just confirm that by running, and we get true down here. Okay. Now, if we do it the other way around, we print names two dot is subset of names one. Well, this case we're going to get false because it's actually a superset, which we're going to talk about in a moment. So we get false, right? Because names two includes everything that names one has and additional items. So it's a superset. Now, like I said, there's a method for that. So we could do print names two dot is superset names one, and since it is, this will print true. Okay, so we get true down here. All right, so that's is subset and is superset. Last thing I want to talk about is frozen sets. So we're going to create a new Python file here, 033 m underscore set underscore is frozen set is what I named this. Okay, so let's create a dictionary here. We'll say my dict equals, and we'll have name, Tim, age 46, GPA 4.0. And what we're going to do is we're going to do my underscore frozen set equals, we can use a function called frozen set, a built-in function, and we'll pass in my dict here, and let's print out my frozen set. Okay, so if we do that, we notice we get GPA, name, and age. So we are taking a dictionary and getting the keys. So we are getting the keys of a dictionary using this technique. Okay. Now, that's pretty much what I wanted to show you. You can try and mix it the other way, but again, sets don't have a particular order. So it's not necessarily the best thing to do. So I actually don't think I'm going to show you that. I think that's it for this part of the tutorial. I hope you enjoyed it. If you did, please give it a like, as it will help get out to more people. Also consider subscribing, as it really does help the channel grow. I also want to thank you for watching, and I hope to see you in the next one. Have a great day.